Flying thousands of feet in the sky and zooming sensors in on enemy movement below, the Air Force Manned Joint Surveillance Target Attack Radar System has been using advanced technology to gather and share combat-relevant information, circle above military operations and share key intelligence, surveillance and reconnaissance data with Service Command and Control. Since its combat missions during the Gulf War in the early 1990s, JSTARS has been an indispensable asset to combat operations, as it covers a wide swath of terrain across geographically diverse areas to scan for actionable intelligence and pertinent enemy activity. The JSTARS mission is of such significance that the Air Force is now evaluating multiple industry proposals to recapitalize the mission with a new, high-tech, next-generation JSTARS plane to serve for decades into the future. However, while Air Force officials plan to continue its pursuit of a new JSTARS platform, service weapons developers now say the Air Force is contemplating the prospect of developing different systems, platforms or technologies better equipped to perform the JSTARS mission in high-threat environments. The circumstance has left many to wonder about just what kind of path forward the Air Force will ultimately pursue when it comes to its longer-term aerial battlefield surveillance mission. The Air Force remains in source selection for a follow-on to JSTARS as we continue to evaluate alternative approaches for battlefield command and control that could be more effective in high-threat environments. In the meantime, we plan to continue flying the current JSTARS fleet through fiscal year 2023, Captain Emily Grabowski, Air Force spokeswoman, told Scout Warrior. Although we are exploring options, there are many steps still to be taken before any force structure proposals are included in the 2019 budget. JSTARS is able to acquire and disseminate graphic digital map displays, force tracking information and, perhaps of greatest significance, detect enemy activity. Information obtained can be transmitted via various data links to ground command and control centers and, in many instances, connected or integrated with nearby drone operations. The Northrop B-8C surveillance aircraft can identify an area of interest for drones to zero in on with a more narrow or soda straw sensor view of significant areas below. JSTARS can detect enemy convoys, troop movements or concentrations and pinpoint structures in need of further ISR attention. In an interview with Scout Warrior earlier this year, Lieutenant General Arnold Bunch, Military Deputy, Office of the Assistant Secretary of the Air Force, Acquisition, said the service has upgraded some of its existing fleet of JSTARS but still needs to develop new technology for the future. While Air Force officials did not elaborate much on the various future threat conditions currently informing the calculus of decision-making, there has been much discussion of a broader need for air surveillance assets to operate in a more contested, high-threat, near-peer type warfare environment. Given these dynamics, broadly speaking, it makes sense that a larger, and therefore more detectable platform like JSTARS could be a more vulnerable target against adversaries with sophisticated weapons and sensors. Accordingly, while JSTARS functions with great effect in lower threat combat circumstances, such as Afghanistan, where the U.S. maintains air supremacy, its size, configuration and radar signature are such that it could potentially be more vulnerable to advanced enemy air defenses. At the same time, the platform is known to add tremendous value in combat scenarios, and advances in aircraft defenses, countermeasures, electronic warfare and newer sensor technology, it seems, could potentially enable JSTARS to operate successfully against sophisticated enemy air-to-air weapons and ground air defense systems. Clearly, the aircraft is not intended to fly at the edge of combat, unprotected, against enemy fighter jets and air defenses. The question is what kinds of assets, emerging systems or supplemental technologies might be leveraged to expand its mission functionality in more contested areas? There are many likely reasons regarding how this could be possible. Attack aircraft or stealth bombers could eliminate air defenses before a JSTARS enters a high-threat area of operation, thus enabling it to operate with great effect. Electronic jamming aircraft such as the AN-18 Growler equipped with a high-tech next-generation jammer, also, could potentially detect and jam radar signals from enemy air defenses, and semi-autonomous drones operated from a JSTARS cockpit in the future might test enemy air defenses or assess the threat environment while the surveillance aircraft operates at a safer distance. JSTARS is specifically engineered to survey wide areas at great distances. Moving into the future, there may be emerging assets able to perform these missions more effectively against extremely advanced enemies. Newer EW and sensor technology, for instance, are rapidly evolving such that smaller, better protected platforms might have occasion to track wider areas at increasingly longer ranges, all while maintaining a lower radar signature. Faster computer processing speeds, enabling a smaller hardware footprint, coupled with more hardened networks and data links, might enable smaller, new platforms to gather, organize, analyze and disseminate crucial, combat-relevant information in near real time. In short, command and control technology is evolving so quickly that the Air Force might wish to ensure it can consistently identify and leverage the best emerging technical solutions able to perform the requisite surveillance and command and control functions currently executed by legacy JSTARS planes. This could lead to an enhanced, new JSTARS recap platform, as is the current plan, or some kind of modification. Given the aforementioned sphere of technological possibility, there does appear to be ongoing inquiry into the question of whether a different platform or technical system might succeed in performing the JSTARS mission more effectively in contested, near-peer or higher threat environments. Would emerging drone surveillance technology, historically thought of as providing a soda straw view of areas below, be able to survey wide swaths of dispersed terrain across a combat area of operations? Perhaps stealthy platforms, increasingly equipped with advanced sensor technology, could perform some of the wide area command and control missions currently taken up by the JSTARS. It may be that a new JSTARS platform could operate in tandem with other systems, networks and aerial platforms able to assist the mission in higher-risk environments. The Air Force plans for new JSTARS to be operational in 2024. JSTARS is a critical airborne extension of the Theater Air Control System and provides ground-moving target indicator data to the ISR enterprise. Air Force official Captain Emily Grabowski told Scout Warrior, "Ground Moving Target Indicator, GMTI, is another essential element of JSTARS technology which can identify enemy movements below. Combatant commanders require unique command and control, and near real-time ISR capabilities to track the movement of enemy ground and surface forces," she explained. Grabowski emphasized that the JSTARS recap will be a commercial derivative aircraft designed to keep pace with rapid technological changes and reduce life cycle costs for the service. JSTARS uses synthetic aperture radar to bounce an electromagnetic ping off of the ground and analyze the return signal to obtain a rendering or picture of activity below. Since the electronic signals travel at the speed of light, which is a known entity, an algorithm can then calculate the time of travel to determine the distance, size, shape and movement of an object or enemy threat of high value. JSTARS planes, which have been very active supporting combat operations in Afghanistan, have flown 130,000 combat mission hours since 9/11. Although initially constructed as a Cold War technology to monitor Soviet Union tank movements in Eastern Europe, the JSTARS has proven very helpful in key areas such as near North Korea, Iraq and Afghanistan. The platform has also succeeded in performing maritime missions in the Pacific Theater, Southcom, U.S., Southern Command, and Central Command areas of responsibility. The JSTARS has been able to help meet the fast-expanding maritime demand for ISR and command and control due to an upgrade of its radar to enhanced land maritime mode, Air Force officials said. The current JSTARS is based on a 4-engine Boeing 707. Of the 16 JSTARS currently in the Air Force inventory, 11 of them are operational. The JSTARS is the only platform technically able to simultaneously perform command and control as well as ISR, Air Force developers describe. The crew of an existing JSTARS, which can go up to 21 people or more, includes a navigator, combat systems operator, intelligence officers, technicians and battle management officers. However, technology has advanced to the point wherein a smaller crew size will now be able to accomplish more missions with less equipment and a lower hardware footprint. Advanced computer processing speeds and smaller components, when compared with previous technologies, are able to perform more missions with less hardware. Northrop Grumman is offering a Gulfstream G550 jet engineered with a common software baseline to allow for rapid integration of emerging commercial technologies. By building their aircraft with a set of standardized IP protocol, the aircraft is designed to accommodate new software and hardware as it becomes available. Size smaller than other offerings, the G550 is intended to fly at higher altitudes and operate with less fuel, Northrop developers said. Our G550 business jet can fly higher and see more to prosecute more targets without any added cost. Its agility and size allows it to be closer to the fight because it can base at 2 times the number of bases that heavy aircraft can fit in. Alan Metzger, Vice President, Next Generation Surveillance and Targeting, Northrop Grumman, told Scout Warrior. Higher altitude missions can widen the aperture of a sensor's field of view, therefore reaching wider areas to surveil. Northrop's G550 JSTARS have flown 500 hours and gone through simulated in-flight refueling behind KC-135 and KC-10 tanker aircraft. Developers say the aircraft has all-weather performance ability, provides VHF-UFH radio operations and optimizes radar performance with a layout creating no blockage from engine cowlings or wings. The G5050 is compliant to wide-area surveillance Common Open Architecture radar processing system requirements, Northrop officials said. Along with General Dynamics' own Gulfstream, L3 is also partnering with Northrop on the JSTARS recap. Lockheed's Bombardier business jet, built by Sierra Nevada, offers a modified Global 600 aircraft with Raytheon-built battle management systems. The aircraft is 94 feet long and can operate with a 100,000-pound takeoff gross weight. Lockheed developers claim the Global 6000, which currently flies in the Air Force inventory as the E-11A, can reach a range of 6,000 nautical miles and altitudes of 51,000 feet. Lockheed also emphasizes that their offering places a premium on common standards and open architecture. Rather than using unique or customized hardware and software approaches adapted to an open systems architecture environment, our architecture is truly open and free of proprietary interfaces. This allows us to leverage state-of-the-art commercial technology to expedite integration of capabilities and minimize cost, a Lockheed statement